Today I will be discussing the concept of monocoque structures, another stiffening concept. These are structures where the skin supports all the load as well as providing the stiffness. It is characterized as being one single piece. Examples of this concept are integral machine structures and sandwich structures. An integral structure, as can be seen in the photo, is machined from a solid piece of metal and has as an advantage that it's low cost and that it reduces the number of parts in your aircraft. It is also easy to adapt the thickness as you machine the part, and even though there's a lot of scrap material, that is not really a problem as metal can be easily recycled. The downside of integral machine structures is that the machining process limits the type of stiffeners to simple shapes only. Another major disadvantage is that once a crack has been initiated, it is free to grow continuously, whereas build-up parts contain natural barriers that stop or delay the crack. This is why an integral structure is considered less damage tolerant than a build-up structure. As to machining, such a part is most cost-effective for 6 skin panels and is mostly used for larger aircraft. A sandwich structure, such as this one, consists of 2 smooth faceplates made from metal or composites with in between a low-density core. In fact, you probably have seen it before in your average cardboard box, which is also a sandwich structure. The core of these structures can be honeycomb, made from either polymers or metals, or made of foam. Structurally, they work analog to the principle of an I-beam, where the web carries all the shear load and the flanges carry the tension and compression loads. The core functions as the web and the face sheets as the flanges. Sandwich structures have it as an advantage that they have a high bending stiffness and therefore need no stringers. This is one of the reasons why this type of structure is often used for floor planning. From the table you can see that a sandwich structure can be much more stiff and have greater flexural strength than a sheet of solid material of the same thickness, with a weight increase of only a few percent. The downsides are that the structures are difficult to repair. Also, joining them to other structural elements is not easy, because many traditional bonding methods, such as riveting and bolts, are not possible. They also suffer from corrosion in metal-based sandwich structures and delamination in composites. They tend to absorb moisture, which does affect their durability. To highlight the issue of corrosion, we take a look at a French maritime patrol aircraft, the Breguet Atlantique. It developed substantial corrosion issues due to water retention in its aluminium honeycomb, as can be seen in the X-ray photo taken in that period. The moisture remained trapped inside and increased the rate of corrosion. This problem of water retention is not just limited to metallic sandwich structures. In 2005, an Air Transat Airbus A310 had to perform an emergency landing as it lost a large part of its composite rudder in flight. The subsequent air safety investigation discovered that the moisture had been absorbed and trapped inside the sandwich panel, causing rapid delamination of the face sheets from the core. This delamination was the result of the moisture freezing and therefore expanding. As with all structural stiffened concepts, there are pros and cons for every one of them. What is right for your design depends on your requirements and will be unique for each design. In aerospace, we don't do one-size-fits-all solutions, only tailored ones.